Okay, so the first thing we're going to look at is the word median. The median, the word itself means the middle of the data or the 50th percentile. It's literally the number that when we consider to be all the data, we consider 50% to be above that number and 50% to be below that number. So literally the middle of the data. In order to calculate the median, we must put it in numerical order first, and then we count. And then what we do kind of depends on whether we have an even set of numbers or an odd. So if we have an odd set of data, then there is a single middle value that we look at to calculate the median. And if there's an even set, then we look at the middle two numbers and then we actually average those. So add them up, divide by 2. And N, just in case you're wondering, actually means sample size or the number of data in our set that we're analyzing. All right, the next idea is the word mean. This refers to the arithmetic mean. In a statistics course, you might see the symbol mu. Looks like a U with a lopsided piece to it. Represents the population mean, and then X bar represents the sample mean. And you'll see words like parameter to represent the population and statistic to represent the sample. And the formula to calculate the mean, pretty straightforward. Add up all the observations and divide by the total number of observations. This, by the way, this fancy looking E is called sigma. It simply means that we're going to sum up a series of numbers. And then last but not least is the mode. The mode is referred to as the observation that occurs the most. Data can have more than one mode, and if we have a set of data where nothing shows up more than once, then we actually don't have a mode at all. And generally speaking, the mode is not very useful. We don't do a lot of things with it, so there you go. Okay, so let me jump back to the word median for a moment, and I mentioned that how you calculate your median depends on whether you have an even or odd set of numbers. So let me kind of walk you through the two different scenarios and how would one generate that. Suppose we've got a number of lollipops in a certain store and a sample of 5 customers. We record how many lollipops they buy. So in this case, we've got 5 observations, and we want to start by making sure they're in order, in which case they are, so great. And then the median would be the middle observation. So we just start partnering up the two ends and keep going until we get to the dead middle, and then this is what we call the median of that data. Now, suppose we add an extra number, so now we have 6 observations instead of 5, and so the median would be the average of the middle 2. So same idea, start partnering up the ends, and I go until I get the middle, and then I want to add up the middle and divide by 2. So 4 plus 6 in this case is 10. 10 divided by 2 gives us 5. And so the median of that set of data is 5. Okay, so at this point I want to take just a brief moment and talk about using a spreadsheet program to calculate the mean and the median. So I'm going to use this off of Excel. Now you might not have access to Excel, but you should have access to some sort of spreadsheet program which will speed up this process. And if there ends up being a face-to-face in class setting, this is something, a calculator skill that I could walk students through, but if you're taking this class online, then having a spreadsheet would be fine. And if the commands that I'm about to show you do not work for your particular program, you can actually Google search a lot of this and look up how to do it that way. Or you can shoot me an email and I'm more than willing to kind of help you figure out your particular software program. So in Excel, I want to take this list of numbers that we just looked at to calculate the mean on, and I'm going to type them in a column. sorry, I haven't typed them correctly in a column. And I'm going to go off to the side here, and I'm going to type equals, and we're going to start with median. Now, as I start to type, the word median actually shows up as a choice. And then I can take my mouse, highlight those cells, and close parentheses. And when I hit enter, it will actually calculate the median for me, which is kind of nice. Another thing that I will talk about is if I want to sort data. So if you highlight the numbers you want to sort, there should be some sort of data tab and then some sort of function that says A to Z or Z to A. So if you A to Z it, it'll put it in order. If you Z to A it, it will reverse the order that it's in, but it will automatically sort it. So if you don't have data in the correct order, you can sort it that way when I do this. All right, and then if I want to do mean, now notice as I try to type mean, it doesn't do that. I wish it did, because unfortunately, the way Excel finds the mean, it actually measures it using the word average, which is what we're talking about, is when do you want one average versus another. So if you type the word average and highlight the numbers, it will calculate that for you. So that's kind of a quick way to use Excel, and so we'll kind of use Excel or maybe a calculator to speed up some of the numerical processes in the next couple of problems we're going to work. Okay, so we're going to return to that lollipop example, and we're going to adjust our numbers. So let me kind of get to the new numbers. Okay, so let's say we switch the 12 to a 20, and then we'll go back through and calculate the same numbers. So I'll let you kind of either do it by hand or reorganize it. But in this case, the median turns out to be the same number it was before, so we add up the 4 and the 6 and get 5. And the mean, again, add them up and divide by the total, get 7.17. So the mean gets bigger, different than it was with the 12. So 12 becomes 20, we get a higher mean, but the median stays the same. Okay, let's do that same trick again, but this time let's switch that 20 to 50. And let's recalculate this. I'm trying to go somewhere with this, so bear with. So the median, again, looking at the middlemost set of numbers, is 5. And the mean, again, add them up and divide by the total, the mean is 12.17. Okay, so what happened? What are we actually dealing with here? And we're dealing with something called an outlier or extreme data. Anytime we have something that's well beyond the norm, we kind of see this impact on the mean, whereas we don't see it on the median. But as we get more and more extreme data, we see that the mean is influenced by that, which brings us to a nice word called resistant. Resistant simply means any statistic that's not affected by outliers. And so as we noticed, the median is a resistant measure. So yes, it's resistant, and the mean is not. So we're going to revisit this, but we're going to go look at some more vocab words about different types of graphs that data can be influenced by, and then I'll kind of show you some Excel stuff about drawing graphs. So when we talk about shapes, there's 4 main shapes that we're going to address. The first of which is what we call symmetrical, or you might have heard this called normal. It refers to data in which both sides are more or less the same. So the left half kind of looks like the right half, and it's sort of bell-shaped or mound-shaped, has a single like this hump in the middle. Then we hit uniform. Uniform data, it refers to every type of number we have has the same, approximately the same frequency. Kind of looks like a rectangle. Then we have skewed left or right. We'll actually come back and look at specific examples of this graph, but this is when we have a mound towards one side of the data and what looks like a tail or a smaller part towards either the left or the right. And we actually name the skewness by the tail. So where the least amount of data is determines whether it's left skewed or right skewed. And then the last type that we'll briefly look at is something called bimodal or multimodal. And this refers to when data has more than one mound or more than one hump that describes the most often observation. Okay, so the left graph is what we'd call symmetrical data. The right graph is something we would refer to as bimodal. Okay, this is what we'd refer to as sort of a uniform distribution. It's not required that they all be the same heights, but you can kind of see that it looks kind of like a rectangle. It's okay for in data to have a little bit of variety. And this is what we refer to as left skewed or right skewed. Again, notice that the tail is on the left side, so we call it a left skewed data, and the tail is on the right side here, so we call it a right skewed data. And then this is sort of what I was trying to illustrate earlier with median versus mean. If there's extreme data or outliers, like we looked at with the lollipops where it went from 12 to 20 to 50, our extreme values were on the right side and it pulled the mean higher than the median. We didn't look at this example, but if we had left skewed data, then the mean would be pulled towards the left side of the number line versus the right. One of the characteristics of symmetrical data that we actually use to define it is if the mean and the median are approximately equal, then we get to say the data is symmetrical. Okay, so let's take a second and let's talk about some real life connections and what kind of data would one expect to see, whether we expect it to be symmetric, left or right skewed, and maybe why. So let's start with the heights of 100 women. If I just go out and randomly grab 100 women and just measure how tall they are, I would expect there'd be a couple really tall ones and a couple really short ones, but all of them would be about the same height. So this would be an example of something that I would expect to be symmetric. Okay, number of books read during a school year by fifth graders. Okay, so let's kind of think about this for a second. I think most fifth graders are fairly consistent. They only read what's required of them. But you got a couple of kids that really get excited about reading. And over the summer, they're just picking up books like you wouldn't believe. And so while I expect most fifth graders to only be reading the minimum amount of books that the school would require, I would expect a few of them on the upper end towards the right of the number line to have much higher numbers of books that they would have read. And in skewness, skewness is defined by where the smaller or the tail is located, so I'd expect that to be right skewed. And the third scenario is speeds of cars on a road where a visible patrol car is using radar to detect speeders. Okay, so we've all kind of been in this situation where we're driving down the road and we suddenly see a cop. Now, hopefully all of us are going to say things like, well, I wouldn't slow down at all. I'm currently going the speed limit. There's no reason for me to be nervous. But that's not really what we see, is it? Usually if there's a cop where we didn't catch it till the last second, we normally hit the brakes. And so typically that's what you'll see, is you'll see a lot of people that are going about the right speed and won't have to slow down that much. But you'll see some people that are very nervous and will really slow down. Make it kind of obvious that maybe they were going a little too fast before they noticed the police car sitting there. So in which case, because I'd expect a few extreme slowers, then this would be an example of left skewed data.